Stargazers, my name is Joe Grida. I'm the Technical Information Officer of the Astronomical Society of South Australia, and I'd like to welcome you to the sky for this month of January 2021. And as we always do, let's draw the curtains on our star chart. There we go. And there's a map of the night sky as we'd see it around about the middle of the month, in mid-January evening. We'll start with the west because that's where the stars set off first. So let's just zoom in on that area. There we go. And stars like the constellation of Pisces and Aquarius that kept us entertained with their deep sky objects during spring are now leaving us, setting quite early after sunset. So we won't see them again until about August next year in our evening sky. But there's lots and lots to see as we move around the sky. You can see Mars here in the northwest, still relatively high in the sky and still accessible to a telescope, but of course it's much further away from Earth than what it was back in October a couple of months ago, when it was a mere 65 million kilometres away. That distance has now grown to well over 150 million kilometres, so much smaller object in your telescope. Let's move around the sky over to the southwest. Again, some of the southern constellations like Grus and Pavo are getting lower and lower in the sky. Not much use trying to observe objects in those constellations through a telescope for the next few months. Over in the south, the pointers and the Southern Cross are starting to rise in the early evening again, and that's always a great pointer to the summer coming nicely in our part of the world. And of course, this area is just covered in many interesting deep sky objects that we'll talk about in another month or two as they get a bit higher up in the sky. Of course, high up we've got Canopus and Acana. Canopus, the brightest brightest star in the southern sky, the second brightest star in the whole sky, after Sirius over here, nice and high now in the east. Canopus is used by spacecraft as a means of locating themselves in space. Sirius, the closest, the brightest star in our night sky, is just a mere 9 light years away, whereas Canopus is about 130 light years away. Canopus is a very bright star. Low in the eastern sky, we've got Hydra, the longest constellation in the sky. Really, this is an autumn constellation, so you can start to see that the sky is starting to rotate over our head. The summer Milky Way is not quite overhead yet, but give it another month or so, and that'll be nice and high in the sky. And then the autumn constellations like Hydra and Leo, which is just below the horizon, will start to show their face. High up in the northeast, of course, we've got probably the most spectacular of all the summer constellations, Orion, the mighty hunter of a Greek mythology. We've also got Gemini, the twins, with Castor and Pollux are here, very easy to see low in the northeastern sky, and Capella in Auriga stands mostly on its lonesome. When you're looking very low in the sky, most of these fainter stars will be absorbed by the atmosphere, but Capella still shows up very nicely. Got the stars of Taurus, Taurus the Bull here, with Aldebaran. We'll be spending a bit of time in this area of sky tonight as we go through this presentation. There's lots and lots to see in this area, and as we've travelled around the sky, we're back towards the northwest with Pisces and Mars still shining nice and brightly. Let's move on. Right, moon phases for January 2021. Best time for evening observation is the middle of the month, between the 6th and the 19th of January, when the moon has achieved its last quarter. Therefore, it's rising after midnight, so you've got nice dark sky in the evening, and it won't be really an annoyance to deep sky observers until around about the 19th of January, when it starts to set, perhaps an hour or two after sunset. And during in between those times, early in January, between the 1st and the 5th, and then again from the 20th to the 31st, we've got a moon in the sky. So you can either treat yourself to some views of the moon during that time, or perhaps have a look at some double stars. Moonlight doesn't really affect double stars at all. As I always do, I always try and find an interesting a feature on the moon for you to aim for each month. And this month, it's one that's called Mons Rumca. This is not an easy object to observe through a telescope, because, as you can see on the full moon picture here, it's very close to the limb, and visible really when the moon is only a couple of days from being full. So you've got a very, very bright moon. But very interesting, this object for this month, because this is where the Chang'e spacecraft, Chang'e 5 spacecraft launched by China to retrieve samples on the moon, landed there only a month or so ago, and has now returned safely back to Earth with lunar samples. This is a sort of view, high magnification view, that you would get through your telescope. So, what is Mons Rumca? Oh, here's another picture from Apollo 15, giving you a different view of this feature. And this one shows it even better from the Lunar Reconnaissance Orbiter, giving you a view directly from above. Now you can start to see what it really is. And let's talk about that. As I said earlier, best viewed around about 12 days after new moon, or 2 days before full. So in January, around about the 25th of January will be your best time to have a look at this. As you can see there, it looks like a pimple, a huge sore. It's an isolated mound of volcanic matter that's just been pushed up from below the surface, located in the northern part of Oceanus Procellarum, which is this big sea here. And as I said earlier, it's the landing site of the recent Chinese Chang'e 5 mission. You can see here where it landed. Actually, this is an interesting chart of the moon, which shows all the lunar landing sites from the Apollo missions, like these dark blue ones here. Here's Apollo 11 over here. Sorry, this is Apollo 11. This is Apollo 15 there. The Surveyor missions, and then the Russian lunar missions, and now the two Chang'e missions from China on this side of the moon, Chang'e 3 and Chang'e 5, which happened just in early December. The feature was named after Carl Ludwig Runke, who was actually the first director of the Parramatta Observatory outside of Sydney, and he held that position for 9 years between 1821 and 1830. Any variable star observers watching this will be quite well aware of quite a number of double stars that he discovered in the southern sky, and all of these stars usually have a RNK designation. So next time you're looking at one of those RNK doubles, this is the man that discovered those. The mound, as I like to call it, this mound here, it's got a diameter of 70 kilometres and a maximum elevation of around about 1,100 metres above the surrounding plains of the Oceanus Procellarum. And we get a better view of it again if we come back to this lunar orbiter view. There's around about 30 domes on this mound. You can see them quite clearly here, and these are shield volcanoes where lava has very slowly bubbled up and just kept on depositing layers upon layers on these little shield volcanoes, and some of them are a couple of hundred meters above the surface of the mound. You're never going to get such a great view, but always interesting to try and pick some of these features up in your telescope. After all, when the moon's up there, there's not much else you can look at. So take advantage of it. Right, the planets in January 2021. The inner solar system, we see Earth leaving Mars behind. That's why that distance is getting bigger and bigger. Earth moves twice as fast around the sun that Mars does, so it'll just keep leaving it behind constantly. Venus, a morning object at the moment, but soon to become an evening object for us by late January, early February. With the outer solar system, well, we've just seen the Jupiter and Saturn conjunction. You can see here from the inner solar system map, the Earth is on the other side of the sun, so the Earth is on this side. So now we've lost Jupiter and Saturn in the sun's glare. And talking of the Great Conjunction, hopefully many of you got a chance to have a look at it. I was sweating the whole time because we've had such cloudy weather here in Mount Barker, where I live in South Australia. But we were really lucky. On the night of the 21st, all I had to do was walk out my front door, stand on the veranda, and have a look at the planets, first through binoculars, and then I put a telescope to them and got a similar view to what you see here now in this picture. This is for one of my Facebook friends in Italy, who sent me this picture, and then one of our own members, Colin Hill from Gawler, sent me this picture that he took of the conjunction. I really like this one because whilst the moons of the two planets don't really show up all that well, there's one here and one just there, but the features on the planets really show up well. The rings, the banding on Saturn have come up really well, and on Jupiter, the bands again have come up really well. And you can see the bright spot here, which is the great red spot of Jupiter as well. So congratulations, Colin. That's a really, really good shot. Probably one of the best I've seen, I would say, of the conjunction. But if you missed this one and you'd like to hang around for a little bit and see a really, really good one, here it comes. You can't see, well, you can. I can't see it here now because I've got a little bar across the date and time. But from memory, June the 21st, 7,541. So if you can wait that long, you'll be able to see Jupiter and Saturn very close together. They're almost sharing their moons here. Of course, don't forget, this is a line of sight thing. Saturn will still be twice as far away as Jupiter is. But in some parts of the world, you'll actually be able to see Jupiter slide in front of Saturn. But you're going to have to wait 5,500 years for it. Right, let's start having a look at the morning sky this time. On the morning of the 12th of January, around about just after 5 o'clock in the morning, look towards the east. Make sure you've got a clear eastern horizon, because you can see how low they are from just above the horizon. And you've got Venus and the very thin crescent moon. Venus and the moon are only separated by 1 lunar diameter, so they're very, very close. See it close up here. You can see how thin the moon is here. This is a great opportunity for you to try and catch a very thin lunar crescent by using Venus. All of this will fit easily in the field of view of your binoculars, even low-power view in a telescope. And of course, you'll be able to see the lunar features using Earthshine alone. So it'd be great exercise for you to get out and look at that. Over in the evening sky, on the 21st of January, we got a conjunction of Mars, the planet Uranus, and the moon, which I think on that day is around about 8 days old, so just past first quarter. Again, the line of sight thing. The moon is only 400,000 kilometers away. Mars is 164 million kilometers away. And then Uranus is 2.9 billion kilometers away. Much, much, much further. And the Mars and Uranus will be separated purely only by 1.6 degrees. So a pair of binoculars will show them in the same field of view. You won't be able to miss Uranus. It'll look like quite a bluish star, magnitude 5.9. So it's quite bright. So it shouldn't be an issue being able to see Uranus, and contrasting with the very deep orange of Mars. So great chance for you to catch Uranus in the same field of view as Mars on the 21st of January. Now we move to the night of the 25th of January, around about 9:45 Adelaide time, and you'll find that the 12-day-old moon will be sitting right between the horns of Taurus, the bull here, Belnath, and Tiuguan, the other star in the horn of Taurus. The moon will be sitting right between the two of them. If we bring the constellation figures up, you'll be able to see, here's the bull, there's his horns, and the moon sitting right between the horns. This area of sky here is where we're going to spend the rest of the presentation on. There is just so much to see in this area. So let's just switch the figures off and come back here. And the first object we'll go to is right at the hand of Orion, the hunter. This extension here is the club that Orion is holding. But right here, right by his hand, there's a lovely little star cluster. Best viewed with a low power in a telescope. Binoculars, I think it's just going to be too small to be able to see it properly. It's a star cluster by the catalogue number of NGC 2169, but it's also known as the number 37 cluster, and you'll be able to see why when we magnify that area. Here it is here. There's the 3, like that, and then the 7 just there. So the number 37 cluster. My wife always makes fun of this. She says, "Joe, just imagine if it showed us 42, then the answer to everything would be right there for us." It was discovered by William Herschel in 1784, located 3,600 light years away. So it's quite a long time away. The light from those stars left about the time that the Egyptians had started finishing their oldest pyramids. And as I said earlier, apparent diameter is only 7 arc minutes. As comparison, the moon is 30 arc minutes in diameter. So you really do want low power in a telescope. Say around about 50, 60 times will show that up really, really well. Okay, moving from Orion's hand over to the shield that he's holding up, because all this time is fighting Taurus, the bull over here. Right at the end of one end of the shield is another star cluster, which I find quite fascinating as well. This one's called NGC 1662. It's an open cluster, so it's quite a wide open aggregation of stars, all gravitationally bound together. And here's a picture of it here. You can see here, as I say, it's quite loose. Those stars there. Again, discovered by William Herschel in 1784. I couldn't find what night he found it, but I suspect, seeing it's so close to the 37 cluster, that I reckon he found it probably around about the same night in October. Magnitude 7, again, fairly easy to see. This is a bit larger than the 37 cluster, 20 arc minutes. That's about 3 times larger. So again, use low power. Around about 50 or 60 times is quite good. I'm not sure if any of you Star Trek fans have yet picked up the shape of that cluster, but let me help you. There it is. There's your Klingon battle cruiser. That's what that looks like from Star Trek. There you go. You see that now? I reckon it looks great. Let's zoom in on the area around the horns of Taurus, the bull. And right next to Tianguan, over here, we have a little object called M1. When you take a long exposure photograph with a very big telescope, this is what you see. This is called the Crab Nebula, and we'll talk about that in a second. This is very well exposed, very long exposure, taken with a very large telescope. I think it may have actually been Hubble. But this is what you would see when you look at it through a telescope. Little fuzzy, cloudy area. So what is it that we're looking at? We're looking at a supernova remnant. A supernova remnant left over when a star exploded in 1054 and was recorded by Chinese astronomers. The nebula was then discovered by an English astronomer in 1731 by the name of John Bevis. It's called the Crab Nebula. If we go back to our previous picture, not quite sure that I'd see a crab there, but in drawings made by the Lord Rosse back in the 1700s, it said it reminded him of a crab. So it got its name as the Crab Nebula. And this object found its way into a catalogue created by Charles Messier, a French comet hunter, who started creating his catalogue in the 1780s, a catalogue of objects to avoid when looking for comets. And this was the first object that he put into his catalogue. That's why it's known as M1, Messier object number 1. And as I say there, the nebula was the first astronomical object that was identified which corresponded with a supernova explosion that had been recorded earlier. It's about 6,500 light years from Earth, and since 1054, that expanding shell of material that was ejected during the supernova explosion has now reached a diameter of 11 light years. Give you an idea of the size of that, our nearest star, other than the Sun, is a stellar system called Alpha Centauri, which is 4.25 light years away. So this shell of gas has been expanding for almost 1,000 years, and it's now reached to be almost 3 times the distance between the Sun and Alpha Centauri. It's expanding at a rate of about 1,500 kilometers per second. Great little object to view through a telescope. You can glimpse it from suburban skies, but obviously any of these deep sky objects are much better seen through a telescope in a dark sky. But something I'd completely forgotten about until I was doing a little bit of research on the Crab Nebula. Before I go to that, at the center of the nebula lies a pulsar, the leftover remains from the star that it exploded. This is the leftover nucleus. It's only 28 to 30 kilometers across. It spins very, very fast, of 30 times each second. Now, in 2003, I think from memory, yes, in 2003, they actually used that pulsar beam and the X-rays coming from the nebula over here. It just so happened that Saturn passed in front of the nebula, and the moon Titan, astronomers were able to observe the X-rays from the nebula traveling through Titan's atmosphere, and when Titan's atmosphere blocked those X-rays, they were able to measure how thick Titan's atmosphere was. I thought that was absolutely brilliant. Right, as I said, this is the field of view here. This part of the sky, it just doesn't stop with all sorts of interesting objects to look at. The arrow is now pointing just above the 3 belt stars of Orion here, and there's another star just there. So let's enlarge that area. Here we go. Here's the 3 belt stars of Orion: Mintaka, Elnanam, and Alnitak. And just up there, just below the red arrow, is Sigma Orionis, another fascinating star. This is one that you can look at when the moon is in the sky. Moonlight isn't going to affect you whatsoever. A photograph of that area shows the famous Horsehead Nebula, very close to it. This is Alnitak here, one of the 3 belt stars of Orion. This is the Flame Nebula, as they call it, and here's Sigma Orionis just there. So what is Sigma Orionis? Sigma Orionis is actually a system of 5 stars that are gravitationally bound and orbit around a common center of gravity. That common center of gravity is centered around this pair of stars here, called A and B, Sigma Orionis. They are massive stars. They're very close together. Even a large amateur telescope cannot separate them apart. But they have a combined mass of about 35 suns, and each of them are more than 30,000 times brighter than our sun. So these are massive young stars. They'll use up their helium and hydrogen very, very quickly, and will probably only live 500 million to 1 billion years, if that. They will have eventually they will explode as supernovae as well. But they have another 3 stars that also orbit around the system, labelled C, D, and E. These 3 stars are very easily visible through a telescope. And just by coincidence, in the same field of view, you got another group of 3 stars, Struve 761. These are quite widely separated, so very easy to glimpse in a telescope. Here's a drawing from Jeremy Perez showing Sigma over here and Struve 761 over here. Nice field. This is at 240 times. He's looking at it. So anything above 100, 120 will still show all of these in the same field very, very nicely. Now you're probably wondering how I generate all of these charts, star fields that I show you each month, and most of those are generated using a piece of software called Stellarium. It's available for Linux, for Mac, for Windows. There's even a web version that you can access. It's free, so you're more than welcome to go and download it, install it on your machine, choose whichever operating system you have, choose the version for it, and go for it. You can customize it for your location, and it is a great tool for you to use. I encourage each and every one of you, if you haven't already got a copy of this, what are you waiting for? Go download it, and you can then have a look at any part of the sky that you want. Did you want to simulate perhaps what the Star of Bethlehem was? I'll give you a hint. Go and have a look at June the 7th, 3 BC, and you see Jupiter and Venus very, very close together. And that is your lot for this month. Thank you for watching. I hope you get out there and actually do some viewing. If you have any questions, there's my email address, technical@assa.org.au. I encourage you to email me with any question you have, and you can get more information about Astronomical Society of South Australia activities at our website. Encourage you to subscribe to our YouTube channel for many of the talks that we record and put up there for you to have a look at, and also follow us on our Facebook page as well. Thank you, and I wish you lots of clear skies. Thanks for watching.